Hi, my name is Björn Boltoft and I'm Product Manager for Exadata Management in Enterprise Manager. This session is Tips for Managing Exadata Cloud at Customer and Exadata Cloud Services with Enterprise Manager. The agenda for today is Performance Hub Exadata Statistic, New Exadata Cloud Target, and Chargeback. Let's start with Performance Hub Exadata Statistic. How do I find all Exadata related performance statistics on my Exadata database? If your database are located on an Exadata machine, you have the AWR report, and there is a section that provides detailed Exadata statistics, both for your database and some additional statistic that includes all other databases that using I/O on the Exadata machine. But this section is rather comprehensive and it is not easy to understand all of it. So how do I become an expert in interpret the Exadata AWR statistics? In Enterprise Manager 13.5 release update 10 and later, we have now added a new tab in the Database Performance Hub page. So instead of generating AWR text report, you will have all this data available with just one click. First of all, your database needs to be on an Exadata machine and it needs to be discovered as an Exadata target, either as an on-prem Exadata or as an Exadata Cloud target. It is only available on a target that is either non-container database or a container database at CDB level. It will unfortunately not be available on PDB level. So how do I find it? By selecting Performance Hub, there will be a third option, or if you have access to the Database Performance Hub from any of the other options, then you can switch to the Exadata tab. The information that is provided on the page is storage related information, so there will be no compute node information. When selecting the Exadata tab, there will be a summary page with the most important statistic. You can see information about open alerts and if there are any disks that are offline, which can explain performance degradation. Storage server CPU utilization and how much the storage grid have been used. I/O requests per disk, also called IOPS. I/O throughput in megabytes per second. The latter is not only provided per disk, it will also be available as a system total. There is one tile for flash disk and another tile for hard disks. As a database administrator, it may not be easy to understand if there are more capacity on the storage system or if we have reached maximum capacity. So we have provided a switch that allows you to compare IOPS and throughput based on the total capacity on the storage grid. There is always an I/O latency in the system and we provide details on the latency, small reads and writes and large reads and writes. If this information isn't enough, then we can drill down and get even more details. Let's look at this in a live system. The Exadata tab is accessed from Database homepage, Performance Hub, Exadata. Here we have the Exadata statistics with an overview of disk usage. In the upper left tile, there is a storage server CPU utilization, I/O request, and I/O throughput. In the upper right tile, there are information about I/O latency for different I/O types. The lower left tile provides information on IOPS and throughput for flash disks. In the lower right tile, we display same information for hard disks. You can also see if there are any open alerts or if there are any offline disks. Let's look at this in more details. There are 9 different tabs, where the first tab is the same as in the overview. We can now go to the Health tab and see details on our alerts. There is an intrusion detection and it's the same for all storage servers. There are no disks offline, but otherwise it would have been reported here. No Exadata ADDM findings. So let's have a look at top consumers. We can see that database CDB1 is the top consumer on this system and EDM1 is the next database in consumption. There is a big difference in I/O usage. The relation between IOPS and throughput indicates that CDB1 is more of a warehouse database while EDM1 is an OLTP database. We can also see details on IO Resource Manager queue time and that it affects CDB1. Next tab is details on cell level. Here we can see how IO requests are distributed on storage cells, so we can see if the IO is evenly distributed or if there are more IO on one or another storage cell. We can also see this information on detailed information for each individual disk. Next tab is around Smart IO. Bytes requested, usage of index, flash cache, among others. Then we have the IO reason tab. Here we can see how much of the IO that is buffer cache reads and how much of it that is Smart IO. The last tab is about storage configuration, hardware and software versions, storage utilization, and available storage. So this ends the demo. We have not just improved the visibility for the database administrator, we have also improved the visibility for the Exadata administrator. So let's look at the new Exadata Cloud target. The management and monitoring of an Exadata Cloud environment differs from the management and monitoring of an on-prem Exadata in the way that as a customer you will not have access to all components. DOM zeros, ILOMs, switches, PDUs, and storage servers are all managed by Oracle, and the only component of these that can be monitored by customers are storage servers. As a customer, you have only access to DOM use and what's installed on the DOM use, such as databases, ASM clusters, and listeners. In the past Enterprise Manager, there was no visibility into storage servers, but with the introduction of the Exadata Cloud target, this changed. So how do we discover an Exadata Cloud target? First, we install agents on DOM use. Then we discover databases, clusters, and all other components on the Exadata Cloud target. Next, we promote it to an Exadata Cloud target. This can be done in two ways. If your Enterprise Manager works in offline mode with no direct contact to OCI, it is done by EM CLI, using a property file with server details and other information, like passwords and so on. If your Enterprise Manager is connected to OCI, then it's possible to use the Discover wizard in Enterprise Manager. In this case, it's more about credential information than providing server names. The Exadata Cloud target has two different appearances depending on if it's an online or offline discovery. The offline discovery has been available since EM 13.4 and includes an overview of all components on the machine. You will see all databases and other targets on the homepage, including its software, version, and status. On the left upper tile, we display names of DOM use and storage servers. Storage servers are gray and indicates that we can only monitor but have no management access. From this page, we can drill down to specific DOM use, storage servers, and storage grid, or to a database to see more details. Another major benefit is that since we have monitoring access on storage grid, it's also possible to use our predefined Exadata storage grid performance KPIs provided by the Exadata Maximum Availability Architecture MMA team. The online discovered Exadata Cloud has another appearance. Here we can see more details about the configuration. If you are using VM clusters on your machine, it is possible to see how each VM cluster is configured. The amount of OCPUs, memory, and storage, both grid and local storage. It's also possible to see other details such as current usage for each VM cluster. It may that you have allocated 12 OCPUs to the cluster, but the actual utilization is around 2 OCPUs. There will be another tab where you can see all databases and other targets, including its software, version, and status. This page has another benefit compared to the offline page. It is possible to see relations between targets, such as which ASM, cluster, and databases that are running in a certain cluster. We can also drill down to a specific DOM use, storage server, or storage grid, or to a database to see more details. And we have the same ability to monitoring the storage grid, and it's also possible to use our predefined Exadata storage grid performance KPIs. So let's take a look at the new Exadata Cloud target in a live environment. To reach the Exadata Cloud target, go to Targets, Exadata. The last target is discovered as a cloud at customer with OCI connection. Select the target. It will now display the configuration of the cloud target. The rack is sliced into several virtual clusters, including one autonomous cluster. There are details on each cluster: how many OCPUs, how much memory, and how much Exadata storage and local storage that is allocated to each VM cluster. By hovering over one slice in the diagram, then you can see which cluster it is. Next tab is for resource usage. We have allocated a certain amount of CPUs, but how much of it is in use? This can be seen on this page. It includes a memory tab with memory allocation and memory used. Next is a member tab, and here we have the details on software for each components. We can also see relations between targets, so by expanding a virtual cluster, then we can see all hosts, clusters, ASM and databases on this virtual cluster. Last tab is about network configuration for the VM cluster. By selecting a VM cluster, we will have a more detailed view. Resource allocated and database versions installed. And then we can see allocated resources compared with used resources for each node in the cluster. Finally, let's have a look at the storage grid for the Exadata machine. If you are familiar with the Exadata target, this is the same information as for an on-premise Exadata, with I/O performance, I/O activity, and configuration of ASM disk groups with its capacity. This ends the demo. So let's take a look at what Chargeback can provide us for the Exadata Cloud target. You have deployed and you start to monitoring and manage your new Exadata Cloud infrastructure. It is also rather common to install a large amount of databases on it. So now we need to understand how it's used, which may also include billing to different departments for usage. In our complete lifecycle for the database, there are metering and chargeback. And with Chargeback, you will get information about capacity used and capacity available on your Exadata machine. So why should we use chargeback and metering? There is an increased demand from our customers to have more detailed utilization reports. When you pay for a service, it's also necessary that the system has the correct utilization. If I'm allocating 20 OCPUs, it's important that we don't end up with a 5% utilization, just because everyone wants to assure that they get the resources they want. One of the benefits of using cloud is to take control of your cost, and by that you should only allocate resources according to your need. You should not allocate 100 OCPUs just because you have a peak that needs to be covered, when average usage is 10. Instead, you should burst CPUs when you need additional resources. This is what Chargeback can help you with, by knowing the cost and how much of your resources that's allocated and what's not used of allocated resources. So even if you are using cloud, it is important to know what's used and by whom. So first, let's take a look at how to set up Chargeback. The workflow for enabling Chargeback is: start with a charge plan. This is about how much to charge and which resource to metering on. There is a universal charge plan which only contains CPU utilization, memory utilization, and storage utilization. This should be sufficient for most use cases. It is also possible to create extended plans which includes more options, both more usage metrics such as the number of SQL statements executed, IOs, and other metrics. And it's also including configuration metrics such as option used or different rates for different database versions. Next is to define cost centers. This is in hierarchical structure, so we can roll up costs for all underlying cost centers. Cost centers can either be entered manually or they can be loaded from legacy LDAP. Next is to enroll targets in Chargeback. All targets need to be added in Enterprise Manager, but Chargeback uses its own data warehouse, so when the target is enabled, we start to collect long-time chargeback data on the selected charge plan. As soon as the target has been added, we should assign charge plan and cost centers to each target. Now we start to collect data and can generate chargeback reports. We have both summary reports and trending reports in Enterprise Manager. Reports can be generated at different levels, like all cost centers or a specific cost center. Same for entities. We can generate reports on pluggable databases only, host only, or all entities. One thing that is important is to make sure that costs are not double booked. If you have 10 databases on a host, then we will have CPU utilization for each database, but there will also be host CPU utilization of minimum same amount. When displaying summary reports, there is also a details tile with corresponding information, which can be extracted to an Excel report for further analysis. It is also possible to publish same reports using BI Publisher in different formats such as PDF, Excel, among others. As a complementary to summary reports, there is also trending reports. Here we can follow the usage trend day by day and month by month. Default is to show 1 month at a time, but it's also possible to show usage trend for long time periods. One of the problems with Chargeback is that most of the charges are based on utilization. So if we decide that a CPU hour costs $1 and my average CPU utilization is around 5 OCPUs, then it doesn't matter if we have a server with 10 or 20 OCPUs. The billing will be the same. So the instrumentation with a fixed bill is rather dull. In general, we want to have as high utilization as possible. This can be solved with a new chargeback calculation called recharging. This gives the ability to provide billing reports that are based on a fixed bill, like when you allocate a cloud resource, which has a fixed bill based on the amount of OCPUs allocated. The method is that we distribute the actual cost from the OCI bill and any other cost that may apply. That may apply to a group of targets based on the utilization for each target. Since we know the utilization, say 70% in total, then we also know how much resources that's still available. In same example, 30%. So in this case, the bill will be split in utilization and unused resources, where unused resources can be split proportionally for usage on all targets or collected into a separate bucket. In the first case, it will help application owners to do their math and only request resources needed. Or in the second case, it helps IT organization to increase the consolidation density. The advantage of cost recharging is that it has an instant calculation, so instead of having fixed month as the default chargeback, then we have a flexible time range. It could be a few days of the month, or if OCI billing is from 5th to 5th next month, then that is also possible. In addition to utilization, it's also possible to add base charges, such as 20% of the cost should not be distributed on utilization. It is the monthly allocation fee instead. So to recap the difference between traditional chargeback and recharging. In Chargeback, you have a fixed rate based on the charge plan, and you have a variable usage. This gives a variable cost based on the usage. If you use 1 CPU hour, then you have to pay 1. If you have 10 CPU hours, then you pay 10. This becomes unpredictable for the service owner and will also not drive consolidation from application owner side. With recharging, there is a fixed cost and a variable usage, which will provide a variable rate. In total, we need to distribute the fixed cost. So if I'm using 1 CPU hour but have allocated for 10 CPU hours, then I still have to pay for 10. This will help drive consolidation. No one wants to pay for unused resources. They will either ask for downsizing or for someone to share their environment with. The process for recharging is select entities from already chargeback added entities. Provide the cost period including the total charge. If there are different entity types, add such as host and databases. Provide a split for each entity type. Split on chargeable metrics such as 70% for CPU, 10% for storage and 20% as base charge. Chargeback will estimate the hourly cost based on usage. Generate the chargeback report. Overview report is charge per entity, while the detailed report is per day and entity. This report can be exported in either JSON or CSV format. And if this calculation is going to be reused for next month, then we can save it as a template. The report looks like this. Here we have a report for 9 pluggable databases. There is usage charge, which is based on CPU utilization and storage utilization. There is a column for unused charges. This is the headroom of available CPU resources on the machine. There is also a field called adjustment. This is if the agent has not collected data for a certain time period, then we estimate the usage for this time based on the normal utilization. Unused charges can be per entity or per host. In this report, we have allocated the cost to the host and not split on individual PDBs. When split on PDBs, unused charges will be in relation to usage charge. The conclusion is that Enterprise Manager has a comprehensive set of tools to manage and monitor your Exadata Cloud solution. It provides DBAs, Exadata administrators, application owner, and service providers with information to use Oracle Exadata Cloud solutions cost efficient. For more information, go to oracle.com Enterprise Manager. We have a video series, youtube.com Oracle Enterprise MGR. We have blogs, blogs.oracle.com, documentation, and you can also try our hands-on lab using the Oracle Cloud free tier. It's now open for question and answers.